Hello, so in this video we're going to be looking at basic integration. It's going to be integration which arises from like the power rule. After you differentiate from power rule, then if you are going back to what you had for power rule. So say we know that from the differentiation, if you have s cubed, if you differentiate this, say y is equal to s cubed, and then you differentiate it with respect to x, so you have y prime equal to your 3x squared. Then what we have with integration is like this formula above. We have 1 over x n dx, which is equal to the integral of x to the n. You know, when x moves up, you have negative exponent, so it's negative x dx. So what we do is we add 1 and then we divide by 1. Remember, when you differentiate, when you're going this way, you differentiate, you have like 3 times x, then you subtract 1. With integration, you add 1. So let's look at it. So we're going to do like this example. We're going to try and move up. So when we move up, we integrate. So how are we going to do this? So it's the integral of what? Of 3x squared dx. And what we must know is that like we can take out a constant. So we can have your 3 and then the integral of what? Of x squared dx. So what we do is after it is this form, what you know is you add 1 to the exponent and then you divide by it. So what happens is like we still have this 3. I just want to deal with this integral. So what we do is we add 1 to the exponent. So you have what? Your 1 over your 2 plus 1. So it's this part. And then you have x to the power 2 plus 1. And then plus c. So this is 3 over 3 x to the third and then plus c. I know that is 3c, but it really doesn't matter because we don't know the constant. So you can see that this is same as s cubed plus c. And we have arrived to this part. So that's how you actually arrive. And the constant c, it just means that like when we were differentiating, we had say plus 5. So if you differentiate 5, you're still gonna get your 3x squared. If this was 15, you're gonna still get your 3x squared. C just means that like there was a constant when we were deriving that we actually not sure of, that we just don't know what the constant was if we are now in this form. What we can try to get back is this part. We can't get back like what was the constant before. So that's what we that's what that's what like integration does. So let's look at further more examples that we have here. So I'm just gonna remove this part and then we're going to look at these problems that we have. So let me remove this part as well. So for this problem, let's look at problem number 1. So for problem 1, we have your integral of x to the 5 dx, and it's already in this form. So it's already in this form. Then what you do is you just add 1 to the exponent and divide by it. So you have 5 plus 1, and then you have x to the 5 plus 1, then you add the constant c. So this is same as 1 over 6 x to the 6 plus c. So that's it for the first problem. So we're going to look at now the second problem, okay, without wasting time. So for the second problem, we have the integral of what? Of your x plus 3x squared, then minus 5x dx. So what we can see is that we have common factor here, so we can just group this. So this is same as 3x squared, then minus 4x, because it's x minus 5x dx. But this is same as 3x squared dx, then minus 4. Okay, let me just say the integral of 4x dx. Of course, you could have taken out the constant same time. Then what we can have, this is just the same as what? As your 3 divided by 2 plus 1, then x to the power 2 plus 1. Then minus what your 4, then divide by what? It's exponent 1, so it's 1 plus 1, x to the power 1 plus 1, sorry, not the x, then plus a constant c. So you see that I didn't add the constant here and then the constant there. It really doesn't matter even if you add it. Like that's what I said, like with the first problem, you really don't have to multiply and have like 2c or something like that, because it's just a constant that we don't know. So this is the same as what? As x to the third, then minus 2x squared, then plus a constant c. So what you may also notice is that some people won't even bother like separating these integrals, but I just wanted to show you that you can do it. So what you can just do is just integrate everything from here. So you have 3 times what? Times 1 over 3, because it's 2 plus 1, x to the third, then minus 4 times what? Times 1 over 1 plus 1, which is 2, then x to the 2, then plus c. So you can see that this is same as x cubed, then minus your 2x squared, then plus a constant c. So that's all for this problem. So we're going to look at another problem. Okay, the third problem. Okay, at least this one has something a little bit funny here. So it's dx. Okay, so the third problem we can have, it's the integral of what? 4x squared dx, then minus 3, and then your integral of what? Of 1 over x to the 5 dx. So at least for this one, it looks more or less like this case, the first, like what we have on what? On the formula that I provided. So what you can do is the first one, you can see it's super easy. So it's 2 plus 1, so it's 4 over 3 x to the third. You can add a constant, but I said you don't really have to. Then you have what? This part, okay, I'll do it a little bit slow. So it's x to the negative 5 dx. So you can see that this is 4 over 3 x cubed, then minus 3 over what? To negative 4. So because it's what? It's negative 5 plus 1. So it's negative 4 x to the negative 4, then plus a constant c. Then you can rewrite it as what? As 4 over 3 what? X cubed plus what? Plus 3 over 4 what? X to the negative 4, then plus c. Okay, so you could have just written it that way. Okay, so let's look at the last one. For the formula, I had specified that x or n cannot be 1, because if it is 1, we cannot really use this formula. So let's look at why it cannot be 1. So if it is 1, like the last problem, which is the fourth problem, it's 1 over x to the 1. Okay, it's the integral dx. So what you can see is that if you do this, you can have what? The integral of what? Of x to the negative 1 dx. Okay, continuing with this formula. Then what you can do is you can try to say this, you add what? Negative 1 plus 1. Okay, still 1 over, then x to the negative 1 plus 1, then plus a constant c. But then now we have a problem of 1 over 0, then plus this constant c, and this is the problem. So that is why we cannot have it. So for this part, what we have for this part, it's, we know that this is same as what? As ln x. The integral of 1 over x, we know that it is ln x, then plus a constant c. Then you're gonna check out my other video, like to explain why we actually have linear x. So it's not really part of this video, so it's really just the basics. Okay, See you in the next video.